what are the applications of machine learning. I explained some of the machine learning techniques. So in this class, for example, if you want to implement a model on machine learning, so for automatically recognition, so here is I taken a small example. So that is better decision making on watching TV without degrading performance of students. So that is the topic is a better decision making on watching TV without degrading performance of the students. So for example, so everyone knows that. So that is the TV is also part of our life. No? So most of the cases, if avoid the students, if I avoid your children to watch the TV, so that definitely the sentiments will be different. So in this case, but if you want to allow the students to watch the TV, how many hours they have to watch? For example, if they watch 12 hours, so then that impact will be fallen on next day examinations. But how many hours you have to allow them to watch TV? So that means here is the correct decision making should be taken by the parents as well as teachers. So most of the cases they were saying, sir, yesterday, so my son was watching TV. That's why. So on Monday he did not perform well. So that is, shall we avoid them to watch the TV or not? But most of the cases the parents are asking. But the same question when they are asking, but I can't say I can't answer. Asking me if they are asking the mission, so the mission will give the correct directions. Either watching the TV is good or watching the TV is bad. Or so suppose how many hours, if we watch 10 hours, how many marks you will get? You will get in the Monday's examinations. But when you are posing this kind of questions, so then computer will give the answers. So in that case, we can use the machine learning technique. So here is in this machine learning, so today's class, I'm going to explain example problem. So the problem I have taken watching TV and getting marks. So data and data analysis. So that means how to analyze, how to make the training data set and a testing data set. Data analytics and types of data analytics. Suppose if you want to design the training data set, so that is how many data analytics you have to follow and how to get the information. And the next one is analysis of linear regression model. So based on this, we can so that is we can get the training data set. So next is analysis of statistical parameter for creating a training set. So the statistical parameters means how accurately our system is giving answer to the parents as well as teachers. So that is Python program for a linear regression model. So that is the implementation method I will explain. So analysis of linear SVM model, if time permits, I will explain the difference between linear regression and SVM linear model. So these are the main contents in the today's session. So the first thing is just I have taken only a simple problem. So then you see that only this is the problem. On this problem, so we can derive the model, machine learning model. Because this is everyone knows that is their children, maybe their students or their friends. So the following data represent 12 different students watch television during the weekends. That means here is I have taken the 12 students data sets. The 12 different students watch TV during the weekends, and the marks of each students who took a test on following Monday are given below. That means in this database, so that is we are taking the 12 students data set. That is the 12 students so watch TV at the weekend. That means on Sunday. So that is when the Sunday they watched the movie. So what impact will be fallen on Monday's examination score? So that is the thing. So for example, just I have collected the data from 12 students. So that is the hours. So that is the first student. He did not watch he watched TV because 0 means 0 hours he watched TV. These are the number of hours watching TV and number of marks those who are getting in the Monday. Suppose 0 hours, he got 96 out of 100 marks, and he watched the second person, he watched 1 hour and he got 85%. 2 hours he got 82 percentage, and 3 hours, so that is 74 marks. Again another person, he watched the TV 3 hours, he got 95 percentage, and 5 hours 68 percentage, 5 hours 76 marks, and 5 hours 84 marks. He watched 6 hours 58 marks, 7. So that is this person, that is the 10th person. So he watched 7 hours and he got 65 marks. So 7 hours, the same 75 marks. Or he watched 10 hours, he got 50 marks. So, but here is when we are taking that, this is the number of hours watching the TV, and next at the weekend, and that impact will be on Monday. Either, so that is either this impact. Suppose when the students are watching the TV, can they get less marks, or they can get maximum marks? But here is, so he did not watch TV, he got 96 marks. So that is, even though, so suppose here you see that, so 3 hours, that is the 1, 2, 3, 4, 5. So the fifth candidate, he watched 3 hours TV and he got 95%, 95 marks. So then here is, but by taking this, if you want to answer for the parents as well as, so to improve the performance of the students, so then we can analyze by taking the data. But here is only I have taken the 12 data sets. So if you take the 1000 data sets, accurate results will becomes. But for explanation purpose, I have taken only 12 data sets. That is the 12 data sets. So general thing is, everyone knows that. So what are the queries we can arise on this case? So first one is, here is I given 14 questions. First one is, see that how many data sets are considered for this analysis. So how many data sets are considered for this analysis? But when you are typing this in the Google, so that is my system will give that, so that is the 12 data sets like this. But second one is that what correlation exists between these two attributes, either positive correlation or negative correlation or no correlation. So that means here is, if the student watched more number of hours the TV, so then how many marks he will get? Is there any relationship? If the marks are decreasing, hours of watching TV is increasing. Or so suppose if you watch more number of hours and you will get more marks. But we can't say that, because based on the data sets, we can't say that either there is a positive correlation or negative correlation. Negative correlation means if one x value is increases, y value is decreasing. So that is the positive correlation means y value increases and x value also increases. But with this data set, so sometimes people, parents will ask, so my son is watching the TV, can he improve the marks or not? Then how do you answer for that, right? So because the student was 3 hours, he got 95 marks, and the student, he did not watch any, he did not watch TV, but he got only 96. So then either you have to allow them to watch the TV or not. So then you have to answer for this question. So if the student watched TV more hours at the weekends, will he get fewer marks or more marks? Sometimes they can ask the question. So suppose if the student watched the TV more hours, suppose 10 hours, will he get more marks or very less marks? But here is also, suppose if there are 1000 data sets, so then it is very difficult to answer for this, right? So suppose you see that fourth question, if student watch TV at weekend, really score will be reduced. Sometimes they will ask, suppose this question, most of the cases the students are asking the teacher, sir, Saturday, suppose Sunday, if I watch the TV, so can I, so I can't, I can get more marks. So then confidently they will say that. But whether it is correct or not. So how many data sets are supporting fourth question? So that is, in this case, a fourth question. If the more number of hours are watching, next, how many you will increase or decrease? That is supporting of this. If you don't want to disappoint the students, how many hours you have to allow them to watch the TV without affecting the marks? For example, 100% it is not possible to avoid the students to watch the TV. But when you avoid this, definitely agitation will start. So, but if you want to allow them to watch the TV, But how many hours relaxations you have to give? How many hours relaxations you can give? How many hours you can wait to the movie? So next, suppose these are the something. Suppose what is the score he acquired if he watched TV 9 hours, but actually what I took the data 12 hours, 12 data sets. There is a no 9 hours. But if you watch the 9 hours, then how many marks he will get? That means you have to predict his mass. When you are given this mass, you have to predict this mass. How many outlier values are affecting the results? So, for example, sometimes one student may be watch TV 10 hours. So then he got 90% of marks. He got 90% of marks. So then what it is? So that is called outlier, right? How many outliers are affected? So what are the mass of students who watch TV maximum hours and minimum hours? Then if you want to answer the question, if one student watches 3.5 hours, how many marks will he score in tomorrow's test? Tomorrow's test, right? So then here is you have to predict the answer for this marks. Then we can say that, sir, I watch TV 3 hours. How many marks I will get in tomorrow's examination? But you should be in a position to answer for that, right? But here is the machine will give answer. As a human being, we cannot give the answer. Even though the student X watched TV more hours, why X scored more marks? Even the X watched the TV more number of hours, he got more marks. What is the reason? What is the reason? So even though the student Z did not watch TV and done hard work, why Z scored fewer marks? If you ask this question, but here is the analytics are required. That is the data analytics are required. Or suppose what is the solution? The 13th question. What is the solution to score more marks even though they are watching TV at weekends? But sometimes the parents give answer, ask the question, sir, my son is not listening my words. He is always watching the TV. But how can he will improve the marks on Mondays? Even he watch the TV. But when they are asking the question, but if these questions, if you ask in other, Google is one of the best example for machine learning. When you type this question, automatically, so you can get the answers. How do you construct the training data set and testing data set? So suppose, so these are the, suppose here is I have taken the 14 questions on the simple thing. So suppose here is hundreds of questions we may ask. For hundreds of the questions, for 100 of the questions, if you answer, so then your system is accurate. But here is if you want to answer for all these questions, the one program is not sufficient to answer for all these questions. Why? Because you can see that. So that means most of the cases, so some are using, we can use the, so that is the SQL you can use for answering the question. That is how many records are there, how many students are there, how many marks are there. But suppose why you got less marks than other person. But in that cases, SQL cannot be sufficient. You can use the data mining techniques, or so suppose the big data analytic techniques we have to apply. So next one is, suppose here is what percentage accuracy rate, the statistics you require. If you want to compare the things, you require the graphs. That means if you want to develop one machine learning, you must be perfect at mathematics. You must be perfect at mathematics. So then only you can do everything on the data. But here is if you want to construct the a training data set. But how do you construct the training data and how do you answer questions, queries for answer for all these queries? But suppose after developing this model, when you keep this model in the Google, but whenever you type, so suppose how many marks I am getting. So that is suppose I watch 4 hours, how many marks I am getting and next Monday's examination. Then immediately the computer will give answer, but you need not to give the answer. Suppose the new faculty, if the new faculty join, so then how many hours you have to allow them to watch the TV or something like this. So if you want to answer for this, then we have to, there are different types of questionnaires also there. Here is, but one is the, so the query languages are required. Our next one is the statistical parameter languages are required. Our graphical representation is also required. But if you are good at all the fields, so then it is you can develop the accurate model. But for as a human being, is it possible to be perfect in all the fields? No, it's highly impossible. So in that cases, so suppose a group of people can develop so the different systems, but here is the only one program is programming language is also not suitable for implementation of this machine learning. Suppose when you take the C programming or Java or Pascal or COBOL or any programming languages are not perfectly suitable for implementation of this machine learning techniques. That means a collection of integrated tools are required. So that's why in the nowadays a Python programming and next R programming languages so are suitable for implementation of machine learning. Why? Because the Python is not a language or R is not a language. These are the a collection of testing, a collection of tools. It is a tool set. It is a tool set like MATLAB, so that each and every component is available in the things of this. So this is the thing. But now I will explain that. But how to analyze the data set before going to give the training data set, but how the data can be analyzed and how to make it as a training data set. First you see that what is the data. So the data is a set of objects. Data is a set of values or set of facts, we can say that. So here is the data is R, but data is a plural or datum is a singular. But in the real life, we are using data is instead of calling R, just we are using data is a set of facts or a set of values. Set of values called data. For example, so suppose when you see that, so in this case, suppose in the today's lecture, that is the more than 150 participants are there. I know that more than 150 participants. So this is the data set. I don't know anything about these 150 participants data. I don't know their names, their qualifications, their place or anything. So that's why, so these 150 participants data is it is called data, not information. So that is a data analysis. But here is, suppose when I am going to teach this one, first thing is, if I am teaching in one way, so suppose if most of the faculty, most of the participants are faculty or research scholars, then it is better to go in depth in the research way. If most of the participants are students, so then it is better to go in the problem solving way. But it's a different thing. Suppose if most of the participants are students, if I will go in depth about it in the research manner, so that definitely, so they cannot understand. But in the same way, while faculty or most of the participants are faculty, so if I am teaching like a subject, so then they won't show the interest. But here is, if I want to know, so before going to teach the subject, but how to analyze the things. For analysis, we can use, this is called data analysis. The data analysis, the process of examining the data to find facts, relationship, pattern, insights, and trends. But here is, in the data analysis, I can take this 150 participants, I can analyze. So that is, I can get the information about all the people. So their designation, their name, so their qualifications. If I get that kind of information, my teaching level should be different, right? So if most of the cases, if all are the doctorates, so then I have to teach more than the doctorates people, right? So in that cases, you have to analyze the data. After analyzing the data, we can get the information, right? But how do you get that in data from that? The simply we can use some query languages like select star from. So that is the Ambedkar University webinar. So that is the, so like this, where there is a name is like, suppose when you are using the query languages, I can get entire information about the participants. So based on that only, I can change my teaching style. So that is the data analytics, right? But here is in the analysis means, for example, data analysis means the data analysis is the process of examining the data to find the facts, relationships, pattern, insights, and trends. So, but in the given data, there are two things are there. One is the mass, and another one is the watching TV, number of hours watching TV. What relationship exists in between two? So, if you want to do that, what techniques you have to apply? So, for example, in the data analysis case, even illiterate, so those who are doing the business, they can use the machine learning. For example, if I am illiterate, I have one ice cream parlor. I have one ice cream parlor. If I want to increase my ice cream business of that ice cream parlor, so then I can use the machine learning technique. So that is the January 31st of this year, January 31st. So that is the how many ice cream cones are keep in my stores for selling. But when you put this question, automatically the machine learning will verify the that is the weather conditions or temperatures. Based on that, it will give the answer. If you follow the machine learning techniques, definitely you can improve his business, right? That is called data analysis. So here is the for classification of data analysis. So next, data analytics. What do you mean by data analytics means? It is a process, but here is the data analytics is a discipline that includes the management of the complete life cycle. Complete life cycle means, I think everyone knows about that. It includes the collecting the data, because they have collected the 12 data sets, or cleaning the data. Cleaning means pre-processing. That means to improve the quality of the data. We can apply some techniques to improve the quality of the data. Quality data always gives a quality results, right? Organizing the data, either you have to convert into unstructured or semi-structured data into structured data. Storing, either that is in what way, in what format we are storing, either in the tabular format or record format or object format, like this. Analyzing and governing the data. So this is the data analytics. So if you want to maintain the training data set, then you have to take the data and you apply 4 analytical techniques. One is the descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So now I will explain each and everything related to my problem, how we can get the values. Descriptive analytics. Descriptive means description about the event. Description about the event. For example, here is the 140 participants are there, 140 participants. But this is the data, but I don't know anything about these participants. If I want to know something about the participants, so simply I can use some query languages. That means you can use SQL. So the select star from, so Ambedkar University server, where from the only that is a sufficient way. So that is the event is, so that is the machine learning and its applications. But when we give this instruction, we can get the entire information about the participants. So that is according to the registration form, So then this kind of things, but in the existing method, so in the taking the students, so if I want to know that how many records are there, how many students have got more than 90%, how many students failed in the category. If you want to know that, so simply we can use the query languages. We can apply a simple query languages, and the output will be kept in the database, one training data set. So sample questions are, you see that, what was the sales volume over the last, was the past 12 months. So when you are asking this what, if the question starts with what, where, then it is better to go for SQL. So what was the sales volume over the past 12 months? If you are asking this question, so which one is the better? Either writing program in Java is better or using the SQL is better. Using the SQL is better. But here is, so for this one, so simply we can take this question, this kind of questions, and we can write query languages. The output is the information. That information will be kept in the training data set. The training data. So in the training data set, right? I understood that the information should be stored in the training data set. But here is in the descriptive analysis, description about the event. That means, so the name of the, so that is entire description will be given in this case. So that is, if you ask the question, how many records are there? I had given that question. But descriptive analysis is better. So that is, so how many, so what is the maximum mass in the data set? What is the minimum mass? So that is how many are, so how many students have got more than 60%? How many students got less than 60%? If you want to ask this kind of questions, then we can use the, so that is the SQL language, that is the query languages, and we can get the information, we can store that in the database. We can store that in the database. For example, so this question we can use. Next, where the company is located, where the company located. So then here is also SQL, that is the descriptive analysis is very, very easy. What is the monthly commission earned by the sales agent? So if you are asking this kind of questions, then we can use the SQL like commands, SQL, DMSQL, or the different SQL language. That is the, after that, the information can be stored in the training data set. Training data set. I answered that. But here is, if I ask why X got very less mark than Y Z. Suppose if you are asking the student why the student got less marks. Suppose when you are asking the question, this descriptive analysis is not suitable. This is not sufficient. That's why we can go for, that is the investigation. For example, so that is when the parent comes to the college and he will ask, sir, how many marks my son has got? Then we can use the descriptive analysis and we can say your son has got this kind of marks. But suppose after seeing that marks, if she asked, sir, why my son got very less marks? Why my son got very less marks? At that time, this descriptive analysis is not sufficient. If you want to solve this kind of questions, the descriptive analysis is not suitable. So that's why we can go for descriptive diagnostic analysis. We can go for diagnostic analysis. Here is the diagnostic analysis. Analytics means causes to happen even in the past. Causes to happen in the past. Causes to happens in the past. Causes to happen events in the past. That means causes to happen in the event past means, but he already got mass. So that is the 60%. If they ask why my son has got 60%, what is the reason? Then descriptive analysis is not sufficient. Then we go for diagnostic analysis. Diagnostic analysis means investigation. So that is, so because your son is not regular to college and so he is not performing well, or some reasons you have to say that. So then what kind of questions you have to get? So suppose why were Q2 sales less than Q1 sales? Suppose why were Q2 sales less than Q1 sales? But when the question start with why, then diagnostic analysis you have to apply. But in that case also, in our data sets also, we have studied that. So that is the why. So that is the X watched more number of hours the TV and he got more marks. But Y watched very less number of hours, he got less marks. Why? What is the reason? But when you are saying this kind of questions, so then here is we have to go for some data mining techniques. That is some algorithmic forms we have to use some data mining techniques to investigate to interactive questions for answering the interactive questions. We can collect the questions which are having the why, so that is the what is the difference or something like this. For answering these questions, we can use the data mining techniques and we can get the information. That information is also kept in the training data set. That information is also kept in the training data set. That means now the data set contains what? The output of the descriptive analysis and output of the diagnostic analysis questions. But when you see the diagnostic analysis, here is the more advanced skills are required. More advanced skills are required. That means, so you must be able to write the programs. Normally we know that classification algorithms, right? Classification algorithms or decision support trees or any fuzzy logic, neural network techniques you have to use for this diagnostic analysis. So in that case, why, what are some questions, right? So next to predictive analysis. So suppose here is, so the, in this case, suppose why my son got very less mass. Then, so with the help of diagnostic analysis, we can say that he is irregular to college. So you won't submit assignments and you won't write examinations. Then we can say the reasons in the diagnostic analysis. Then after that, if the parents are asking, so what action I have to make to get good marks? If the parents are now what we have to do? If they are asking that, you have to predict. So that is why he is not coming to the college regularly. If the parents is asking that question, so you have to predict, right? So then that's why here is we can use the predictive analysis. So outcome of the event in future, outcome of the event in future. Suppose then based on the diagnostic analysis, so you can find the reasons for that. And if you got very less credits, so then what will happen? If you get less marks, what will happen in the future? So if you get less percentage, suppose if you irregular to the college, next what is the impact of that? If you want to know that, that is called predictive analysis. Predictive analysis. Again, we have to apply some predictive analysis. That is outcome of event in future. Outcome of event in future. If the cyclone is happened, so that is next month. So what is the impact of the cyclone? So that is how to overcome that impact. Like this, the predictive analysis. In the predictive outcome of this, so that is here is we can estimate. For example, so in our data sets, you see that. So if my son is in Sunday, my son watched the TV 3.5 hours. How many marks he will get on Monday's examination? Then, so diagnostic is not sufficient, or descriptive analysis are not sufficient, but predictive analysis is required. Here is we have to use the predictive analysis. Predictive analysis. In the predictive analysis, it predicts the outcome of in future. For example, you see that what will be the patient survival rate if drug B is administered instead of drug A? That means what will be the patient survival rate if drug B is administered instead of drug A? That means suppose there are two medicines are there for particular disease. If there are two medicines are the particular disease, so then so suppose if you use A instead of drug A, if you use in drug B, then what is the impact? Either so the curing rate is very high or curing rate is very less or any side impacts. Suppose here is the prediction. If a customer has purchased the product A and B, then what are the chances of purchasing product C? Here is, so when you get this kind of questions, the questions with start with if. So if conditions, right? So then the predictive analysis can be involved. Predictive analysis can be involved. So if you want to predict all these things, suppose if you want to do the predictive analysis, so then we can use some statistical parameters. That is the estimation, we can call it as estimation. But here is some predictive analytical techniques we can apply on the same data, and we can so we can get the answer for this kind of questions, and that output is also kept in the training data set. That kind of data is also kept in the output of the training data set, right? Now you see that, so descriptive, diagnostic, predictive analytics are kept in the one database. We are calling that as a training data set for answering questions. So next one is, but here is, suppose you say that, suppose today my son watched the Sunday my son watched the TV 3.5 hours. On Monday he will get only 40 marks. He will get marks. Then what is the action I have to take? What is the action? Either shall I close the TV, or then what is that? Suppose that is called prescriptive analysis. So then for that kind of questions, we can use the prescriptive analysis. Based on the results which is happened in the future, so then you have to use the rectification. That is the answer should be given. For example, you see that among three drugs, which one provides the better results? Among three drugs, which one provides the better results? If the question start with among, when, or which, so then predictive analytics comes, right? But here is that is the action should be taken. Suppose suppose today you watched the TV 3.5 hours, definitely you will get only 50%. You will fail in the examination. So that is the predictive analysis. When you are predicting that, how to overcome? Even you watch the 3.5 hours, so you allow them to study late nights. You allow them to study in the late. So suppose we can give the suggestions like that. For this purpose, we can use the prescriptive analysis. So that means in the sample questions, suppose when among these three drugs, which one is the best results, when it is the best. For this kind of questions, we can answer. That output is also kept in the training data set. That is the training data set. So now you see that. So suppose here is according to our conditions. So now this is the way of maintaining the training data set or model data set. Suppose whenever putting one question, whenever typing particular question, so the machine learning goes to the training data set and searching for particular question and particular answer. If the question is matching, answer will be displaying. So, but in the Google we can see that. Do you mean? Suppose if you type the question wrong, it will asking, do you mean, or this is like that, warning that will be given. So that means with the help of these four analytical techniques, so we can create the training data set. So the training data set will be kept in the database. But whenever posing the query, it is a testing data. Whenever posing the query, directly it goes to the training data set. So which one is a matching, immediately the data will be displayed, right? So here is what we are giving, but we are not writing any program for this. In the machine learning, we are not writing any program. So we are giving input data is a training data set, and we are testing data set. We are posing the queries. So this is the way of constructing a training data set for any application. So we can use the descriptive analysis, diagnostic analysis, or the next one is the predictive analysis and the prescriptive analysis. So based on these four analytical techniques, so we can create a training data set. We can create a training data set by using the training data set, and we can apply testing data set, so that automatically it will give the answers for questions, right? So now you can see that. So suppose again I am showing that. Suppose here there are different types of questions are there. Then how many data sets are considered for this analysis? So which technique is sufficient? Descriptive analysis, right? What correlation exists between these two attributes, either a positive correlation or negative correlation? So if you want to take this one, diagnostic is sufficient. If the student watches TV more hours at the weekends, will he get fewer marks or more marks? Here is the what kind of technique you have to apply? Predictive analysis. Here is a predictive analysis. So suppose the questions are started with the, if student watch TV at weekend, really score will be reduced. So that is also prescriptive, predictive. How many data sets supporting fourth question? So this is the descriptive. So that is here is the different questions are there. The results will be affecting like this, right? So that is the reason. So then here is for answering all the questions, we can maintain the data analysis, right? So now after creating the data, but here is, so suppose whatever you take the data, create the model, first thing is you have to create training data set. If you want to create training data sets, you must follow the 4 data analytical techniques. One is the descriptive, diagnostic, predictive, and prescriptive analysis. So in that example, you see that what kind of question. Suppose, how many marks my son has got? So this is the descriptive. So then immediately she asks the question, why my son has got very less marks? Then you have to go for diagnostic analysis, right? Suppose yesterday my son watched the 12 hours TV, how many marks he will get? So that is the predictive analysis. But if you will get less marks, what are the remedies we have to do? How to get the first marks? Then descriptive analysis you have to use. So this kind, for answering this kind of questionnaires, so we can use these 4 kinds of data analytics. We can construct the training data set. We can construct the training data set. By using the training data sets, or by using query data, we can that machine will be answering based on the training data set. So here is, so if you want to implement all these 4 techniques, only one algorithm is not sufficient. You have to use a more number of algorithms. So the different kinds of algorithms. By using the different kinds of algorithms, you have to maintain the training data set. Now, for example, you have taken the linear regression. Now I will explain. So that is how the training data set is created like that. But here is, for that application, I will explain how to create the training data set and what are the relations. Next, I will explain answers for this. Here is the theoretical analysis. Just only first you see that linear regression. Everyone knows that in the linear regression, the formula is y is equal to mx plus c. Generally, we can call it as a y is equal to mx plus c. It is a linear equation. So that is here is. But in this case, y is the dependent variable, x is the independent variable, m is the slope, and c is the b is the intersecting points. So, but when you are using this, when you calculate the m value, this is the formula we can use: n sigma xy minus sigma x into sigma y by n sigma x square minus sigma of whole square. B value we can calculate, but everyone familiar about this. So based on that, how do you predict the values? With the linear regression, how do you predict the values? For example, you see that, suppose if you want to predict the values, the same output, here is taken hours, 1 to 12 records I have taken, 0, 1, 2, 3, 3, 5, 5, 5, 6, 6. So the testing score already we have taken 96, 85, 82, 74, 79, 95, 68, 76 or something. Then here is, I am calculating, suppose if you want to calculate the m, we have to use x into y, product of x into y, that is 0 into 96 is 0, 1 into 85 is 85, or 2 into 82 is equal to 168, like this. You have calculated x into y value. After that, x square, 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 3, like this, y square. So the 96 square is equal to 9261, like this. We are calculating all the values. After that, you see that. So the total, you can find the sum. In this formula, we have to find out sigma. Sigma x is equal to 54. Sigma y is equal to 908. Sigma xy is equal to 3724. X square and y square. Sum of x square, sum of y square. So we can calculate all the values. We can calculate all the values for x and y. Then where is, we can calculate, you see that m value we can calculate. But here is, we got the slope is minus 4.067. We got m is minus 4.067. And you can take b value, that is the intercepting point. So then you got the 93.97. The intercepting point is 97.93. Then here is calculate m and b values. So based on this linear regression, we can find the training set. We can find the training set. But here is, for finding the training set, we can apply that point. Suppose, for example, you see that all the points we can take like this. Suppose here is training data set. We can use y is equal to M value as minus 4.07 into X plus 93.97. But here is X we are using. For all the X values, that is the number of hours. Then automatically you can get the number of mass. But you concentrate more because it is a mathematics. So this is also analysis will comes. No? So that is you put more concentration. So here is for each and every X value, suppose 0 hour, 1 hour, 2 hours, 3 hours, 5 hours, 7 hours like this. So you can get the Y value, number of mass. According to that, we can maintain the training data set. Now you see that. So X is the hours are 0, 1, 2, 3 like this. Original mass are what? 96, 85, 82, 79, 74, 95 like this. But the training data set. So after substituting this X value into the equation, we got. But our prediction is, so that is the training data set is contains, instead of getting 96 mass, you will get 93.97. That means according to our training, so that is if you don't watch the TV, you will get 93.97 but not 96. So 85 per 1 hour watching, you got 85. But instead of 85, you will get 89.9 according to linear equation. That is here is we maintain the training data set. But actually 10 hours, when you watch the 10 hours, original mass are, you will get 50 hours. But in the training data set, we got 53.27. That means here is we are maintaining instead of using the direct mass, so we can use the training data set. So with this training data set, we can estimate, we can predict the next values, or we can do anything. So here you see that when you are drawing the graph, the first 4 values, 4 graphs are done. One is the linear, logarithmic, or so that is the simple logarithm, scatter plot, right? Here is, but when you see that this is the actual original mass of students, the line is, you see that zigzag, line is in zigzag. But when you are taking the training data set, we got the straight line. That means the mass which are on the line, so that is the predictive mass. So based on that, here is we got the straight line, but here is there is no exact decisions will be taken. That's why here is the training data set is a very smooth and it is the accurate value. So here is the some outliers will be eliminated, right? So that means here is, do you know how do you find the training data set? So that is we are taking the number of hours and original mass we apply. So that is the linear regression model. Y is equal to mx plus c. We can calculate the m value. We can calculate the c value. So after that, so by substituting x value, we can find the new values for y. So then, so that we can get the training data set, because here is the only numerical data we are taking. So that's why. So that is we are maintaining the training data set. If we take the different algorithm, there is a different methods are using. So after training the training data set, now you see that predicting. Suppose the predicted value, you see that y is equal to minus 4 like this. For example, so here is I had given one question like this. So that is, if the student watched the TV 9 hours, how many marks he will get? But in the data set, there is no student with 9 hours, right? So you can see that 0 hour, 1 hour, 2 hours, 3 hours, 5 hours, 6 hours, 7, 8, 10 hours. There is no 9 hours. But if you ask that question, if my son watched the TV 9 hours, how many marks he will get in the Monday's exam? Then here is, in this equation, we can substitute x value is 9, so that we can get the value 57.34 marks. Immediately we can say that with the help of the training data set, we can say that definitely your son will get 57.34. But how do you say that? Predicting. I answered that how they are predicting. You can give any value. Suppose in this equation, you can substitute the x value 3.5. So then we can get the mass of 3.5 hours. This is the prediction. For prediction, in this equation, we can substitute the given value so that we can predict all the values of this. So then here is, but next to what I had given, the prediction, you can see that for prediction, you have to write this equation. But whenever I was asking the question, so my son watched the 9 hours or 4 hours or 3 hours, how many marks he will get? Then the machine will understand this question according to the training data set, and next it substitute the corresponding number of hours and it produce the output as number of marks, right? This is the predictive. So in the predictive analysis, we can use the same formula, we can predict all the things. For example, suppose if you are given, so what is the relationship exist between watching the TV and getting the marks? If you want to see that, correlation techniques are required. Correlation means it shows the relationship between two values, two pairs. For example, if you watch more number of, second question I had given, if you watch more number of hours, you will get more marks or less marks. If you want to get the question for the answering for this, so then we can use the correlation technique. Here is in the correlation, we can calculate the values of this. It can represent the graphs. With the graphs, we can see that correlation. So the correlation between two objects, how do you calculate? Suppose X is there and Y is there, but you got the graph like this. Then what relationship exists it is? Either strong relation, weak relation, negative or positive. But most of the researchers, so that is the while they are not publishing the paper in the SCI or in the Scopus means, so because they can't, they are not analyzing the graphs and tables in their experimental results. So if you clearly explain the results in the research paper, so that definitely, so that is your paper will be selected in SCI or Scopus. But most of the cases they are putting the graphs, either always they are keeping graphs. Even most of the research scholars, while I was evaluating the thesis, most of the people they can use bar graph, but there is no explanation about that graph. But here is, so before that, if you want to answer the queries like this, then you see that. So the different graph, suppose when you are drawing the graph for X and Y values, if graph is coming like this, so that is the from Y to X is down. That means X increases, Y tends to decrease. So this is called negative correlation. But when you draw the graph in your paper, suppose if the graph is comes like this, it is a negative correlation. That means one is increases and another one is the decreases. But in the, so suppose for the same thing, so we can see the graph. Suppose if the number of hours watch, more number of hours watching the TV, definitely mass will be reduced. So then this is the X increases, Y tends to increases. This is called positive correlation. If the graphs comes like this, it is called positive correlation. So then if the graphs comes like this, no correlation. No correlation means there is no relationship between X and Y. So if the graphs comes like this in the bell shape, we can use this is the non-linear correlation. Non-linear correlation between the two objects. But here is, but when you are saying that, here is we are taking the correlation. How strong the correlation is. Suppose I am saying that, suppose one question you can answer. So suppose if the more number of hours you watch the TV, either you will get the more mass or less mass. That means either positive or negative. But you have to find out. I will explain that. Right? So second one is, this statement is strong or weak. But when I say the statement, sometimes we can say 99% I am correct. How strong it is, how weak it is. If you want to say that, we can calculate the correlation factor of this one. For example, you see that, so the same mass I have taken, but here is I am not the same mass. And when you draw the graph, I got the graph like this. You see that here is, this is the decreasing order, right? Y, X is increases and Y is decreasing. So that means here is, so then here is a negative correlation is there. Here is negative correlation. That means with our data set says that if your son watch the TV more number of hours, he will get less mass. How do you say that? Based on the graph. Based on the graph, because here is the negative relation. The graph shows the negative relation between x and y. But when you say that, so the parent will ask, is it true? How do you say? How much percentage your answer is correct? When they are asking, then you have to calculate the correlation factors. Suppose you see that R is equal to minus 0.95. Suppose if R is equal to, correlation factor we can calculate. This is nearer to 1 or nearer to minus 1 or 0. Suppose if the correlation factor is nearer to minus 1, there is a strong negative correlation. If the correlation R value is suppose nearer to 1, so it is a strong positive correlation. If that is weak positive, suppose you see that R is equal to 0.42, but in the first case R is equal to minus 0.91, that means it's a nearer to minus 1, then we can say that R is a strong negative correlation. But here you see that R is equal to 0.88. 0.88 means it is a strong positive correlation. That 100% we can say that my statement is correct, like that. So weak positive correlation means suppose R is equal to 0.42. It is a, so that is the weak. We can't say that either my statement is correct or not. So no correlation means R is equal to 0.07. It is nearer to 0, then we can say that it is a non-linear correlation. Non-linear correlation. But based on that, we can apply this correlation factor to our data and we can say that whether it is correct or not. For example, you say that the correlation factor we can calculate R is equal to n sigma x into y, sigma x, sigma y, square root of n into sigma x square minus sigma x whole square into square root of n into sigma y square minus sigma x square. But here this is the mathematical formula, that is the correlation factor. But here is for our data set, I can find the correlation factor. So suppose here is when you are calculating this, but here is I got minus 0.831 for our data set for the 12 data records. When I apply the correlation factor, I got the output is minus 0.3831. But what correlation is exist? Negative. Negative means minus means negative. That is the negative correlation. Either it is a weak or strong. Definitely it is a strong correlation. Strong means, so because it is nearer to minus 1. Then we can say that, so that is if the number of hours, if more number of hours you watch the TV, and definitely you will get a less mass. That means there is a negative correlation. If you will get the more mass, you must watch less number of hours TV. Then negative correlation, this statement supports 90% or 60%, like this, right? So then I had given that what correlation exists in between watching TV and getting the mass. So if the student is asking question, sir, what will happen if I watch more number of hours? Can I get marks very less or more? If they are asking questions like this, then immediately we can say that if we watch the TV more number of hours, so then so that is the marks will be reduced. So because our statement, our machine learning technique says that the correlation factor is nearer to minus 1. Right? I will say that I understood that. Here is coefficient determination. That is the correlation factor. We are saying that it is a negative or positive. But how strong it is? How strong it is? Either it is a strong relationship or weak relationship. But when I am saying the statement, I am saying that marks are increasing, number of hours will be reduced. Suppose if the number of hours are reduced, x value is reduced, y value. But here is negative correlation, we can see that. Either it is a strong relation or correlation means, but we have to calculate the R square factor. You have to calculate the R square. But when you are calculating R square, you got 0.691. You got 0.691. That means, suppose supporting, this is called supporting time. And in the data mining already you have studied. So the supporting. So 69% of the people are supporting our statement. That means out of 100, so the 69% of the data sets are supporting my statement. What is my statement? If you watch the TV more number of hours, you will get less marks. This statement is supporting by using this. So that's here is you have to calculate the R square. If you are getting R square is a more, suppose remaining 31%, suppose here is the 30.9% data we can't say. So suppose that will be the random, either it may be correct or not, but that is the random fashion we can take. So suppose if you want to see that, first you have to calculate the R factor, you have to calculate R square. When you are calculating that, we can say that according to my example, I can say that, so if you watch the TV more hours, you will get less marks. The statement is proved. And how many people are supporting that means 69% of the people are supporting my statement. So that's why we can pass on this as a thing. That means here is, do you know how to calculate R and R square? These are the mathematical formulas. So, but here is hypothesis testing. That means here is, for example, we can't avoid the student to watch the TV, right? Sunday, suppose World Cup is there. You assume that, and Sunday World Cup final is there. Can we stop your children not to watch the TV? It is highly impossible. They can fight with us, right? So in that cases, you have to think that how many hours the student is allowed to watch the TV. How many hours the student is allowed to watch TV. But simply I put the queries in the Google like this. So that is on Sunday, my son wants to watch the TV on Sunday because of World Cup. So that is, if you want to get 96% 96% marks in the test, how many hours I have to allow him to? So suppose here is suppose 75 marks. My son suppose on Monday test he wants to get 75%. How many hours I have to allow him to watch TV? That is the 3 hours, 4 hours like this. If you want to test that type of condition, we can use the hypothesis test. Hello. So we can apply the t-test or p-test. Suppose we can calculate the t value. See that t is equal to r by sigma square. That is the variance, standard deviation. But when we are applying this for the same data, we can calculate the t-test value. So then you see that according to our formula, we got -3, t value is -3.169 and t naught is equal to 3.169. So then here is, so in that case, we can draw the graph. You see that, clearly observe that. The minimum limit is minus t naught, minus 3.169 and high limit is 3.169. So then here is, this is called significance area. The area which is in between minus t naught and t is a significant area. So out of that, you can watch the TV. That means, suppose when you say that, for example, here is I am saying that my son wants to read the data. Suppose he wants to watch TV suppose minus 4.72. This is outside. Even minus 4.3, it is outdated. You need not to bother about that. Suppose 3.169 hours if we watch the TV, that should not affect on the Monday's marks. That should not affect on the Monday's marks. Then simply we can say that you can allow your son to watch the TV on Sunday 3.169 hours. So that there is no problem on the Monday's test. Just like, so then we can say that. But here is, we can allow So more than 3 hours, suppose if you allow them 4 hours, definitely 4 hours means definitely. So that is the impact will be fallen in the mass. Impact will be fallen on the mass. So that is the reason. So then here is we can find the boundaries with the t-test. So then you can calculate. We can give the relaxations of that. So one question I had given: if I want to allow my son to get to watch the movie without affecting the mass, then we can give that answer is, so allow your student 3.169 hours. Then here is we can calculate the t-test, and another one is that also p-test is also we can calculate. And that is the same purpose we can use. If the mean value is a 95% and 5% will be given t-test with the help of these values. And f-test we are seeing that f-test, you can see the f-test value you can calculate. So based on that, but when the graph is comes like this, three means are very nearer, then we can say that those are similar. So that is the three are different, we can get the those are the different. For example, you say the standard error condition. So here is you can use the standard error conditions are 96, 85 or something, 8.001. So that is here is the standard. Here is you have to calculate all kinds of these formulas, right? I've understood that. Here is if you want to do the things, so the first one is whatever data they had given, first you have to see that, first you have to construct the training data set. We have to construct the training data set. Here is how did I construct the training data set? So I used the linear regression model and I found the slope and intercepting point. After that, I applied the same value y is equal to, so that is by substituting that x value, I found the new values of y. That is instead of 96, I got 93.97 or like this. So after getting the training data set, next what I have to do that? Then I have to apply. So that is either the what relationship exists in between these two values, either negative correlation or positive correlation. For that purpose, a correlation factor R is calculated. On the after that, so we have calculated R square, either how strong that relation is for calculation, or next t-test, p-test. So for making it either my statement is supporting 90% or 100% like that. After that, we are calculating the minimum standard. There is a standard error estimation. So that is what is the main differences between standard error estimation, either original data and a training data set. Suppose when I am estimating, for example, here is I am saying that, so if you don't watch the TV, you will get 93.97 marks, 93.97 marks. But when you say this thing, when I say this one, so that is either it is a correct or not. If you want to say that, in Monday's marks we can take, and suppose you got 94. So then you can see the difference, 93.97 minus 94. So 0.03. So that is the error condition. By estimation is a correct like this. So that is the error condition can be estimated. By estimating all these things, so we can write the program, and so that we can get the answers of this one, right? So now you see that here is in the Python, for the same thing I have written program. So I think you understood how to create the training data set. You see that. So the first one is in the Python, if you want to implement this program in the Python, so first step is you have to choose the packages and the classes. For example, here is the import packages, but here is each and everything is available, so that you can write your own programs, right? So first import NumPy, that is the numeric Python. Numeric Python as alias name we can, instead of using NumPy, we can use NP. NumPy, that is the numeric Python. Here is the numeric Python can be used to perform operations on matrices or numbers, right? Either most probably the NumPy can be used on matrices, either two-dimensional or one-dimensional matrices. All the operations we can use by using this NumPy package. So then we can download the NumPy package, importing NumPy package. And for all this kind of machine learning techniques, linear regression, SVM or something like this, we can use the sklearn.linear model. Is a sklearn, a linear model package is there, and here is we can use the linear regression or any kinds of neural networks or all the algorithms are available. So that means from sklearn.linear model, import linear regression. We are importing the linear regression. Here is two things are there when you are writing the program. Either you can write your own program and either you can use a built-in model. But here is I took two programs. One is I write my own program and another one is thing. So then you see that for SciPy import stats. So that is from SciPy package. So you have to use the statistical application. Statistical operations are what? You have to calculate the R value, right? So you have to calculate the, so that is the mean value, T values are like this. If you want to calculate these statistical parameters, there are built-in functions are available in the stat package. That is STATS. This is in the SciPy, SCIPy, scientific Python. SCIPy means it is a scientific Python. It contains all the statistical parameters of this one. So next one is we have to draw the graphs, right? Graphs and tables. For that purpose, we can use Matplotlib. Matplotlib package can be used to, so that is used to display the graphs. Variety of graphs we can display by using Matplotlib. As a plot graph, scatter plot, or line graph, or pie chart, or 100 types of graphs we can draw. So that is I have slides also on that. So that is, if you want, I will share that slides also. So next one is import Seaborn as SN. That is, the Seaborn can be used for getting the answers of, that is the T values. Some values we can use the Seaborn, but here is, this is the first thing is, but when you are writing the program, first thing is you have to see that. So that is the import the packages. First step is you have to import the package. Or second step, you have to provide the data. Second step is you have to provide the data. So already in the previous case, I took the data of 12 records, right? The same data I have taken here. But here is the 12 records are there. I am using arrays. If the databases are large, then we can read the databases by using read operations, or that is the import operations. So we can get the data values from the databases. So that is here is also we are taking reshape -1 other. So print the values. So after that, plot the various axis scales. Suppose if we want to draw the graph, we can use plt.subplot. So I have shown that the 4 graphs I have drawn, right? So first graph, linear graph. You see that PLT means that is, here is a PLT means, here is, you see that Matplotlib as PLT. So with the help of that Matplotlib, so we can call the PLP. And for array construction, we can use the NumPy np.array. Within the bracket we have taken 4 graphs, linear graphs, subplot. Suppose if you are good at MATLAB, you can easily understand it. But here the plot or subplot means here is the 4 graphs. That means within that we are mentioning 2 to 1. 2 to means, so that is the graph that area contains 2 rows and 2 columns. That means 4 graphs we can display on the same canvas. So 2, 2. That is the first graph. Plot x, y. X value and y value. And y scale we are mentioning the linear, and the title is a linear graph, and x label hours, y label is the score, and predict grid is true. Suppose when you are using that, automatically that will be draw the lines. Plot graph, a symmetric plot graph, scatter plot. So already I have shown that 4 graphs, right? So next one is a create a model or fit the it. Second one, what I have done, I have created the training data set. So training data set means I substituted all the x and y values, then I kept the values into this. So here is model.linear regression. We can call that is a built-in function linear regression. this linear regression automatically model. This model contains, so that is the model dot fit means automatically it creates a training data set. It creates training data set. So in the fourth step, after creating the training data set, then you have to use the results. You have to calculate the R square. That is the R square we are using. That is the R square means for supporting the statement. So that is the print of R square values, R square. And the next cross checking with the internal SkyP values, T1, T2, P1 values calculation. These are the test. And F test value, plot the residuals, predict response. Here is I am using the predicted response of this. Here is, so then here is when you are writing this program, just if you want, I will execute this program. Answer this. So this is the model we can create, but when we execute this program, so it will give the answer. Suppose whenever questioning the thing, so automatically you can get the answer. If you are given 3.4, automatically you can get it like this, right? This is the program. But if you have taken the large databases, we can use the descriptive analysis. That is the SQL you can use. The data mining techniques are different techniques so that we can maintain the things of this, right? So if you want, I will share this program also. You can execute it definitely. So whatever you ask the question, that question will be answer for this, right? Okay, thank you for listening this, right? So if I want to execute, here is Sir Ramakrishna sir.
Sir, yes, sir.
Sir, shall I execute it? I think it will take
Yes, sir.
time.
Yes, sir. Yes, sir.
Huh?
You can execute it. Yes, sir. You can execute it.
I think it take time.
In meanwhile, any participants can have any doubts, please share with our Professor Nagaraj gar.
Okay, you can ask any doubts. Is it visible, sir?
Sir, it is clearly visible.
But only some part of the program I am executing for getting
Okay.
answers. Because the more techniques are required for machine learning and data analytics. The more mathematics. Okay. Meanwhile, if you have any doubts, you can ask. I will explain that program because have any queries?
Dear participants, if you have any queries, please share with Professor Nagaraj gar.
But it takes time for getting the output. Just you unmute the people, then they can ask the question.
From the students or faculty, any of
Okay.
Good morning, sir.
Good morning, Amma.
Sir, can you
Yeah,
explain the program one more time?
madam.
Program, sir. Can you explain the program one more time?
One more time, right? So that is it's executing. And so with now you see that now. So first one is you see the first we are taking the packages you have to import, right? sklearn linear model, linear regression. Suppose I written only my program here. You see that in this case, the simple case. Wait, I got answer. So after explaining this, I will explain the again program, right? Just you see that first one is when you see that, sir, is it visible? Hello?
Yes, sir.
Proceed.
Yeah, graph is a, so that is what are the graph I taken, you see that? Linear graph I got now. So next one is, so obviously these are the mass we are getting, just wait. So this is the predictive values, that is the training data set value, and these are the residuals. So that is the expectation mass and virtual getting mass. So then that means here is it got the you got 90% this, and here is you see that we have calculated the values. For example, first I have taken the 10 mass, that is this is the first one is you see that these are the number of hours, and here is this is the number of mass, that is the original mass what you got, and here is calculate the coefficient value of r is equal to 0.833 something. In the original case we got r is equal to 0.833. So whatever value I had given, the same value I got. Suppose if r value within the program, so that in the within the training data set we can write if r is greater than 0.5, then it is a strong positive relation. If r value is less than, like this here is, we got r value 0.831. By seeing this r value, we can say that here is, it is a strong negative correlation, minus is there. So that is a strong correlation is there. But based on the graph, we can say that negative correlation, because x increases, y decreases. Already I have shown that. But here is when you are calculating where the 0.83. So next one is r coefficient value. You see that r square. R square is you got 0. Here you see that r square is 0.69100 something. That means the 69% of the people are supporting my statement. And you see that in the equation we got the c value. So that is the y is equal to mx plus c now. So the c value you got 93.97, and you got the m value, slope is minus 4.06. So whatever values I kept there, the same values we got here. So then here you see that predicting t-test. Then I explain the t-test now. For this data set, I got minus 17.3535. That means it is, so suppose the t-test value is minimum to 0.3. But here is I got minus 477. That is, here is the accuracy rate is increasing. Accuracy rate is increasing. P-test value, you see that. So the 2.56 into e to the power of minus 14. P value is also very less. So that's why P value, T values are very less. So that's why we can say that accuracy rate will be high. But based on the P-test value and the Q-test value. So here is I have taken the value. Suppose these are the training data set value. You see that these are the training data set. 93.9700, 89.00. By taking this training data, here is I had given for prediction, but actually in the array. So suppose I had given these values. So these are the responding after fitting the model. So that is the training data set we are getting. So next after that I have written my own here is my own formula I have written. For this also same points we got, right? But in this case, so then here is I have taken the different values. For example, 4 hours. but 4 hours is not in the table. 4.5 hours not in the table. 8 hours, 8.5, 9 hours, 9.5. So these are the values I have taken. I have to find out that if you watch 4 hours or 4.5 hours, 8 hours, 8.5 hours, 9 hours, what is the output? So then the predicted values we got 77.70, 75.70 like this. But the same thing, but here is, I have given the queries like this. For example, enter the predicted value. For example, if I will enter, so if you watch the 3.5 hours, how many marks you will get on Monday? Here is I get 3.5. So when you watch the TV, you will get 79.73 marks, 79.73. So the same conditions, but again we have to use the conditions here. Suppose if you get 10 hours or 12 hours, how many marks you will get? Only 45 marks. Or suppose the 0 hours, so you will get marks of, so that is the 93.97. So suppose 4 hours, we can get 77 point or something. Or so suppose 1.5 hours, or we got the output like this. Here is I taken the 6 queries. But here is when after writing this program, within the program I have to check the conditions for gaining the training data set. So how do you say that it is